So my name is Celeste. Thank you very much for the introduction. A bit about me is that when I originally wrote this talk, it was about November 2025, and I just started my role at Snowflake, so the introduction is that I am new. I had just moved to London the first time I gave this talk. Oh, it isn't working. Slay. Oh, we good? 3, 2, 1. Okay, we're going to pretend like I didn't say any of that. Thank you very much for the introduction. My name is Celeste. This is going to be Writes 3 Ways, and you can sort of see that the subtitle is Newbie Explorations. When I originally wrote this talk in November 2025, I was new to a number of things. I had just moved to London in September to start a role at Snowflake, running the open source programs office and working as an open source developer advocate, which leads us to the topic of this talk. Like I said, I just started at Snowflake maybe about 3 or 4 weeks before I first gave this talk. And as a part of joining Snowflake, I had to learn Apache Iceberg really, really quickly. We had touched on it a little bit in my last role in Ivan, based here in Berlin, but I didn't know a ton about it. And for me, the way that I've always learned best is I like to take something new, compare it to things I already know, and sort of like question mark, profit on it. And I usually like to really isolate that to like one aspect of a system so that I can understand how things work in comparison. So that's how I approached learning Iceberg. I knew Postgres and I knew Kafka because I, again, had worked at a company called Ivan, which does a lot of kind of open source data services as managed services. But Snowflake is like super duper heavily invested in the Iceberg ecosystem. We hire a bunch of maintainers, and so I knew I had to learn about Iceberg. And my conclusion from this, and the update for this talk in June of 2026, where I've been working with the technology for about 10 months now, is the story of writes is the story of understanding different programming paradigms and understanding what the priorities of those systems are over time. So this talk is kind of arranged as a timeline. Because why Postgres, why Kafka, and why Iceberg, they're kind of disparate data services, right? But I think they're also very, very relevant services to the points in time in which they were created, and the sort of concerns that we had as data engineers as we moved through those. So Postgres was created at UC Berkeley. It was very much a proof of concept for relational database systems, and it makes certain assumptions based on the hardware of the time. Similarly, Kafka was created at LinkedIn in the early 2010s, and as social media was taking off, there was a real concern about managing complexity of events and handling that data in real time. In late 2010s, you have Iceberg, which is created at Netflix, where they were managing this huge development team, huge team of data engineers. They were generating so much data comparison to those early 2010 systems. And so they needed to create something where the developer experience was a priority. So we're going to talk about those 3 things. At the very end, we're going to talk about, based on what we've learned, what does this mean going forward, particularly now that we're in the age of agentic coding, sort of uncontroversially. But like really high level, Postgres writes directly to disk, and that makes assumptions about the technology as it was at the time. Kafka writes to message queues on a shared cluster. It is very, very container native or cloud native in its architecture and its concerns. And Iceberg is really a metadata abstraction layer, and where we're going is more of those sort of metadata abstraction layers, is the thesis that I would like to propose, having given this talk 3 or 4 times in this 10-month period. So here's what we're going to do. Very briefly, we're going to talk about the lifetime of a write in Postgres and what this says about the system's design and its priorities at the time, and where some of those assumptions maybe fall over in 2026. We're going to do the same for Kafka, and we're going to do the same for Iceberg. Yeah? Okay, cool. So let's talk very briefly about writes in Postgres. The story of writes in Postgres is really the story of this guy right here, the write-ahead log writer. Basically, anytime you send data to Postgres, it hits the postmaster layer. The postmaster is really just a connection manager. And then the write-ahead log does a lot of heavy lifting in terms of when things actually get written to the disk. When Postgres was created in 1990, a lot of the concern was around persistence of data. It was really, really hard to store data in a way that was persistent, in a way that was consistent, in a way that was uncorruptible, because servers came up and down a lot more than they do now, and we didn't have as good recovery methods. So there was a lot of concern of when things get written to disk in Postgres, we need to make sure that that data is like unimpeachable, basically. So the write-ahead log really does a lot of work to ensure that. So like I said, client to Postmaster is really just a connection manager. But what it really does is it introduces the idea of separation of concerns, which again, in 2026, this seems like a very basic concept, but you have to understand that Postgres was created in the early 1990s. It was based off the Ingress project, which was being sort of defined as thesis work at UC Berkeley in the 80s. And this idea of separation of concerns was not an idea before Postgres and a few other technologies introduced it, right? Similarly, this idea of the postmaster then talking to the write-ahead log, the write-ahead log is Postgres's keystone. Basically, all SQL statements are recorded to the write-ahead log. The write-ahead log then talks to the database, it puts some data in buffer, it runs the operation, and it says, is this going to corrupt anything? And if the answer is no, it didn't corrupt anything, then the buffer becomes what is actually stored on disk, and you sort of garbage collect what's already on disk. And again, I think this seems like a pretty basic idea of an atomic transaction now. In 1990, that wasn't necessarily the case. And this idea of an atomic transaction is very, very important because I would also argue that this is one of the first instances of thinking about developer experience in data systems, and the idea that a human being was going to use this and they needed to have sort of heuristics attached to that so that they could use it in a way that wasn't stupid, for lack of a better word. So like I said, the write-ahead log, if you say, I would like to write a row of data to a table, it then says, okay, cool, I'm going to go find that table on disk, and I'm going to take the last 3 rows of that table, I'm going to put it in a buffer, we're going to try writing this forth, and if nothing goes crazy, we're just going to do a switcheroo with the pointers. And this is, again, like another sort of revolutionary concept that doesn't seem revolutionary in retrospect. And this is actually one of the things that I always like about Postgres, and why even now I recommend it to people who are getting into data to learn a bit of Postgres. It is such a foundational concept, and it contains so many foundational concepts that it'll just give you a good, understanding of the way the world works. So, what we learned. Postgres cares more about accuracy than it cares about speed, I think is the biggest takeaway here. It cares about the data that gets written to disk being uncorruptible, and we didn't really talk about it in these slides, but the reason it cares about the data not screwing up the rest of the database is when you think about deploying software in the 90s, it was like a computer in physical space, and you FTP files onto it or whatever, right? So there was no ideas of separation of storage and compute, which means that if the database itself became corrupted, the entire Postgres deployment became corrupted. And if you look into a lot of what the cloud providers have done, so for example, Google with AlloyDB, Microsoft with the work it's done with Aurora, a lot of those sort of implementations or re-implementations of Postgres, the first thing they do is they separate the storage and compute layers, because in Postgres, they are inherently tangled up even to this day, I would say. And this idea of separating storage and compute is, of course, one of, I think, the foundations of modern computing, and certainly the foundation of cloud-native computing, which is kind of what we're going to talk about next. So let's talk about writes in Kafka. So another boring architecture diagram. Once again, we sort of have an application layer that is managing a connection. Then we have a Kafka client library, and I think that's the next biggest thing to think about is, again, Kafka thinks a little bit more about developer experience, and it understands that developers are working in different languages and on different code bases. So you're always accessing Kafka through a client library, and some of these client libraries behave differently than others. And that's an important sort of thing to think about. For example, Confluent releases client libraries for almost every language. They're not the only Kafka libraries out there, though, right? And this is where Kafka gets very, very interesting in that it is intended to stream real-time data. So we are putting things in stream, we are serializing them. So messages just get serialized. From there, the client library determines what partition they're going to. And that's the sort of second concept that we introduced with Kafka. You only ever deploy Kafka as a cluster. I believe the minimum cluster is 3 nodes, so you've kind of got a main and you've got two dependency nodes. But this idea of like a cluster and like multiple nodes and load balancing is a cloud native concept or a container native concept. Kafka itself is like not a part of the Kubernetes ecosystem, obviously, but it borrows the same ideas because that's what Netflix was trying to solve for at this point in time. It wasn't, can I just get the database up? Can I get my website up? It's, can I serve the same website to millions of people across the globe? Can it be performant across the globe? And if one of these servers or nodes fails, can the system not only recover but continue to thrive, right? So it's a very, very different set of problems. And what this means inherently too is that we have to separate storage and compute, because the storage needs to be replicated across multiple regions and across multiple nodes. And the compute is potentially what's going to fail, so we also kind of want to isolate those nodes when they fail. So the client library defines a producer partition. Over here is where things get a little weird. This is like the multiple node situation in that each partition has a leader broker. This is what Kafka calls a node. And the data is replicated to one, if not multiple, follower nodes. And again, this is to provide failover, which is not a concept that we have in Postgres because we're dealing with different things now. We do a bit of replication. Once we've done that, we come back to the leader node and we say, please write to the topic. We are done. We are correct. And it sends an ACK all the way back to the producer application. The thing you'll notice here, too, Kafka has a message queue, so there are things producing messages and, in theory, things consuming messages, but the consumers exist nowhere on this flow chart. And that's because Kafka doesn't care who consumes messages. For better or for worse, I would argue that a lot of people would feel that not caring about the consumers causes huge issues in any single Kafka deployment that you have. There, in fact, are like multiple side projects to allow you to manage your consumers because it becomes such a problem, but Kafka doesn't care. It's cool. So we already kind of talked about this. I'm going to zip through. I'm actually going to zip through this because I've got the 10-minute warning already. So what did we learn? Kafka is fundamentally distributed in this design. It has a very different set of concerns. Consistency on read is a secondary concern as a result because we care more about replication and failover than we care about a single source of truth. Distributed computing and those ideas are built in as first-class citizens, and that's why Kafka, I think, is so viral, because most systems deployed at scale are distributed systems these days. And it introduces an abstraction layer between writing and when the data is written. Okay, let's talk about Iceberg. This is the one I was newest to, and I didn't update these slides for this, and Danica Fine is giving me a look. So Danica Fine is the queen of Iceberg, if you didn't know. Okay, so a much simpler diagram, arguably, but also a much more complex diagram. So we have less actors in play. Basically, you start the write transaction. You have this idea of a table in Iceberg. It is a table metadata format, and the table has some data. You got to load the table metadata from a catalog, typically. Send it back to the client library, and then you sort of do a write all the way to disk, and then ACK back to the file library as many times as you please. Once that's done, and we'll talk a little bit more about this metadata thing to begin with, we update our metadata, which is written to the same disk as our data, send an ACK, do a commit, swap our metadata for our new metadata, and then we say, hooray, we're done. I think here's a question. Who feels like they understand Iceberg on a fundamental level? Hey, the stream-based guys. You should definitely talk to them as well if you want to talk about Iceberg. They really do know quite a lot. So I think, who here has heard of Iceberg? There you go. So when I first learned about Iceberg, I was very, very confused because everybody talks about Iceberg tables, but they don't really talk about what Iceberg actually is. which is its metadata. It is a YAML file or a JSON file or however you want to store that metadata that describes things that are table-shaped that you can kind of like slap on top of a bunch of Parquet files. That is what Iceberg is as a fundamental piece of technology. And that might sound like overhead, and it is. You don't necessarily need to use Iceberg, but if you're dealing with a moderately complex data environment, you probably want to, because Iceberg is there for you. Iceberg is there for the developer. It doesn't need to exist for the system to function, but it provides a sort of consistent layer of something that is like vaguely table-shaped that you can mostly do SQL-shaped things against. So if you know a bit of Postgres, which like most people know a bit of Postgres, you can kind of do something Iceberg-shaped. And that compatibility is what we care about. And that's the reason that Iceberg is becoming really popular, is it's becoming the standard upon which data services provide a compatibility API. We went through this briefly. We don't got to talk about it too much. This will also, by the way, be the only Iceberg talk you ever see that will not include the one squiggly diagram. So the joke in the Iceberg community is if you give a talk on Iceberg, there's one diagram that shows up in every single talk. And I think as evidence of how new I was when I first wrote this talk, it doesn't show up in this talk. If I were to redo this now, I think it would. But basically, what the diagram looks like is it shows this layer of metadata called like the Iceberg catalog, and then all of these manifest files, which are just, the catalog itself is like a YAML file, and the metadata files are like additional YAML files. And then the YAML files point to Parquet files, which are data files. And these layers of metadata let you do table-shaped things on otherwise unstructured data that lives in an S3 bucket. And that is useful because who here has unstructured data kicking around in an S3 bucket? I was really hoping for more of you, but that's okay. But a lot of companies do. Like if you're storing analytic data, if you're storing product transaction data, if you're hot loading data into other systems, you probably have an S3 bucket somewhere full of random stuff. And Iceberg lets you access that in a table-like fashion. So what did we learn? Iceberg is table-shaped, but not inherently a data store. It's an abstraction layer made of metadata. And it provides a consistent and fairly light way of talking to data services because the implementation itself is lightweight. The other thing it does is because it relies on Parquet files or org files, typically living in an S3 bucket, there is like the idea of storage and compute being completely separate is baked in to Iceberg. It doesn't really conceptually exist without that, which again, in like modern data engineering environments, you're typically dealing with some level of big data, and that matters. So by way of kind of postscript, we need to talk about, we are in the age of agentic coding, and so we need to talk about, well, okay, we solved for different kind of data problems previously, so what do things look like in the AI age? And I think they're heading in an iceberg-shaped format in the sense of we need more metadata, we need more semantic metadata, because the LLMs work better when the data is at least partially structured. You can use them on unstructured data, but they do better with semantics. So a project that Snowflake has been working on for a while now is called the Open Semantic Interchange. You should definitely check out the website. And we're aiming to sort of create a metadata standard for semantic data. So semantic data is, of course, like data that describes your data. It provides meaning to your unstructured data. And if you're working with AI or if you're building AI agents, adding a bit of structure to your data makes them more effective and makes them more token efficient. So I would check out this project. We don't have enough time to talk about it now. I'm done.
Thank you.
Oh, wow, I did not update this last slide. So it's not February. We're not running that meetup anymore.
Do you have questions for Celeste?
Good, let's wrap it up.
Thank you very much, Celeste, for the talk.
Thank you.